How being in space impairs astronauts' immune systems. This is by the Karolinska Institute. A new study led by researchers of Karolinska Institute in Sweden has examined how T cells of immune systems are affected by weightlessness. The results, which are published in the journal Science Advances, could explain why astronauts' T cells become less active and less affected at fighting infection. The next steps in the exploration of space are human missions to the Moon and to Mars. Space is an extremely hostile environment that poses threats to human health. One such threat is changes to the immune system that occur in astronauts while in space and that persists after their return to Earth. The immune deficiency can leave them more vulnerable to infection and lead to the reactivation of latent viruses in the body. Now, I do have a subscriber that is a doctor. Hopefully she will comment on this. I don't know if this could be remedied in some way. Now, if astronauts are to be able to undergo safe space missions, we need to understand how their immune systems are affected and try to find ways to counter harmful changes to it. Study leader Lisa Westenberg, principal researcher, Department of Microbiology, Tumor and Cell Biology, Karolinska Institute said. She says, we've now been able to investigate what happens to T cells, which are a key component of the immune system, when exposed to weightless conditions. In the study, the researchers have tried to simulate weightlessness in space using a method called dry immersion. This involves a custom-made waterbed that tricks the body into thinking it is in a weightless state. The researchers examined T cells in the body of 8 healthy individuals for 3 weeks of exposure to simulated weightlessness. Blood analyses were performed before the experiment started at 7, 14, and 21 days after the start, and at 7 days after the experiment ended. They found that the T cells significantly changed their gene expression, that is to say, which genes were active and which were not, after 7 and 14 days of weightlessness, and that the T cells and that the cells became more immature in their genetic program. The greatest effect was seen after 2 weeks, 14 days. The T cells began to resemble more so-called naive T cells, which have not yet encountered their intruders, and this could mean that they take longer to be activated and thus become less effective at fighting tumor cells and infections. Our results can pave the way for new treatments that reverse these changes to the immune cell's genetic program, says Carlos Gallardo-Dodd, PhD student at the Department of Microbiology, Tumor and Cell Biology, Karolinska Institute, and shared first author with researcher Christian Orlton and Julian Record on the same department. After 21 days, the T cells had adapted their gene expression to weightlessness so that it had almost returned to normal, but analysis carried out 7 days after the experiment ended showed that the cells had regained some of the changes. The researchers now plan to use Esrange Space Center's sounding rocket platform in Kiruna, Sweden, to study how T cells behave in weightless conditions and how their function is affected. The study was conducted in close collaboration with Claudia Cutter's research group at Karolinska Institute SciLife Lab and collaboration partners at IBMP, Moscow, New York University, Abu Dhabi. I never even knew New York University had a branch at Abu Dhabi. Okay, more power to them. This is from Karolinska Institute, Carlos Gallardo-Dodd and colleagues. On Medical Express, please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.